So when I was learning algebra for the first time, and we eventually came to factorizing, I was introduced to these 4 different types of factorizing, how to do them, and when to do them. It was like, use this method if you have 3 terms and all that, which is kind of stupid because they're all the exact same method. They're all the same as this, except you might have to do it more than once, which I'm going to show you why that's true now. So for the highest common factor method, it's quite simple. They both have a factor of x, so you can take an x out. And then because multiplication is distributive, which I'll do another video proving that eventually, we can write this as x minus 3 because this has an x times x. So if you take an x out, we only have an x. This is a 3 and an x. If we take the x out, we just have the 3 and there's also the minus. How do we know these are the same? Because if you expand out this bracket, you'll get x squared and then minus 3x. And how do we know we're allowed to expand the bracket like that? I will show that in another video after this, probably the next one. Then factorizing by grouping is the exact same thing. These both have an x, except we have to do it 3 times actually. We can factorize this one by highest common factor and this one. So here they both have an x. So we can take x and then have a minus b. And then we have plus, and we can factor out a plus y from these. And then we'll have a minus b. And now what we were told in school was take this bracket, write it down, and then write this number, and then write this number. And then it's like, why are you doing all those steps? Like, I didn't understand it. I can never remember it. In reality, you're just seeing we have 2 terms here, just like here. We had 2 terms up here, and we factored out an x out of the 2 terms up here. Here, we can factor out an a minus b out of the 2 terms, like this. So if we factor out an a minus b, then here, if we take an a minus b out, if we cover that up, we just have an x left. And then we have a plus, and then if we cover up the a minus b, we just have a y left. So you can see that's the exact same as doing the highest common factor, except we just had to do it twice here and then once here. The difference of 2 squares is a little trickier. It's that we were told in school, oh, if you have a difference of 2 squares, you use this formula. What's the reason for that, though? If you take it quite literally and look at it as 2 squares, and then you take away the areas, then you get this shape. So if we have this x squared and this y squared, literally, then x squared without the area y squared is going to be this shape. Because remember, this tiny square here, that's y squared. Now, what are the lengths now? Well, this is still x. This is still x. Now, this whole side would have been x, but the thing is we took this length away. So it's this whole length x without this length, which is y. Therefore, this length is x minus y. For the same reason, this one's x minus y. And this length is y, and this length is y. Now, I want you to calculate, I want you to try this, pause the video and try this. I want you to calculate the area of this shape by breaking it up, if you didn't know. And I want you to see if you can figure out this formula by doing that. Because these 2 equations, they're the same. It's the same area, except it's a different way of writing it. So pause the video and try that. So if we do it, you can see the area of this little rectangle is y times x minus y. I'm sorry, this is still equal to x squared minus y squared. It's still equal to that because the areas are the same, as I said. Plus, and then the area of this rectangle is x times x minus y. And then finally, we can just take out an x minus y that they have in common, like in that's their highest common factor. And then here, we just have a y left. Sorry, that looks like a minus y. Here we just have a y left. Plus, and here we have a plus x left. And you can see that's where we get the formula x minus y times x plus y. Well, here it says y plus x, but because multiplication is commutative, you can write it any way you want. You can write it as x plus y as well. And that's where this formula comes from. If you want to think about it a little more algebraically, the way you can derive this is if you have x squared minus y squared, it helps if we have linear terms as well. You can also write that as x squared plus xy minus xy minus y squared. Why does this work? We still have our x squared and we still have our minus y squared as we had here. Then we added something and we subtracted that same thing. So overall, it makes no difference. Now, can you see by using factorizing, can you get this formula from this? Give it a go. Pause the video. So what you can do is you can just take out an x from the first 2 terms and you get x plus y. And then you can take out a y, or a minus y would be better, but it doesn't really matter. If you take out a minus y, it works because they both have a minus y, or they both have a minus, sorry. And then we have x plus y. Because, again, if you're not sure, you can expand it back out. If we took out a plus y, then the problem would be that this bracket wouldn't match this bracket. So that's why we took out a minus y. Or we could do it in 2 steps if we weren't sure. And then you can just factor out the x plus y, and then you'll get this formula. Now for quadratics, again, it's the exact same as what we did just here. We're going to be adding and subtracting a few things, and you'll see the reason why we're going to do that. So we know that if we're adding up numbers like this, sorry, not adding up numbers, if we're expanding a bracket like this and it has an x plus a number and then x plus a number, or of course this number could be negative, if we expand that out, we'll get, so we take this one, multiply it, and then we'll do this one and multiply it into both. Again, this video isn't about expanding brackets. I'm assuming you know how to do that already. So we'll get x squared plus xb, and then we have plus ax plus ab. And what do we notice? Here we get a quadratic, we get something with a squared. We have x squared plus, these both have an x in common, so if we factor out an x, I will actually put the x after. We'll have factor out an x, and then we're left with a b plus an a, and then we have plus ab. So what do we notice about a quadratic? If we want to factor a quadratic, so here we expanded, and then we went to the simplify, we started with brackets, and we expanded it, and we got to here. If we want to go from here and go backwards, what do we notice? Well, the number in front of the x, whatever these two numbers are going to be in our brackets, they should add up to be the coefficient of the number in the middle, and multiply to be the number of the constant. So it's the same here. We're going to factorize this into brackets using two numbers, and they have to multiply to be this one, and add to be this one. And if you do a bit of trial and error, the factors of 18, we could do minus 6 times 3, or minus 3 times 6. You got to just think about which way. You kind of got to mess around with it. This isn't, I'll do a video specifically about quadratics maybe. If we have minus 6 and plus 3, that'll give us minus 3. That's the middle number, tick. And then if we have minus 6 times 3, we'll get minus 18, which is the last number, tick. If you really weren't sure, then you can actually use these formulae here, that we need two numbers, and we need a plus b to be equal to the middle number, and we need a times b to be equal to the last number, which is minus 18. And then you can actually solve the system of equations to figure out what the numbers should be. Anyways, I did it kind of more intuitively, and I figured that they should be minus 6 and 3. And now, why does that kind of help us? Well, you'll see now, we can actually rewrite this minus 3x. So instead of writing minus 3x, we're going to write it as minus 6x plus 3x, and it's the same thing. X squared minus 6x plus 3x minus 18. So you can see, when you simplify this, it's actually going to be the exact same as this, because you add these, and then you get this. And now we can actually factorize this, because these both have a 3 in common, and these both have an x in common. So now what we see is we factor out x, we'll get x minus 6, and then what we can do is plus 3, factor that out, and we get an x minus 6. And now you can see, what do you know, they both have an x minus 6 in common. We get x minus 6 times, and then x plus 3 are the other two left over. So as you can see, it was the exact same as the difference of two squares. We're basically adding and subtracting something. As here, we change the minus 3x, we change it to be this, and then we factorized it using the highest common factor like we did in every single other example. So obviously I did skip over a few steps there, and I didn't say why we're going to rewrite this as whatever, but again, this is kind of like a general quick introduction to why they're all the same. I'll probably do other specific videos in depth on each one. But that's, as you can see there, every single method of factorizing was basically the same. We were just factoring out the highest common factors and doing that in multiple different ways.